Hey guys, welcome back to my channel. And today we're going to get some math problems done. So let's get into it. We're going to continue 2.7, which is talking about radicals and expressions and all kinds of things. Okay. So the biggest thing that I want you to think about when you're working with these is, does it work in number land? Then it should work in radical land, but it just looks a little bit different when you're working with them. So just keep in mind what's the same and what's different. Okay, so let's get started. It says change the form of our focus today is to change the form of radical expressions using properties of exponents. And then here are some questions that you should be able to answer by the end of this lesson today. So which is a more efficient way to change the form of a radical expression, using radicals or using exponents? And how do the properties of exponents help explain methods for presenting or representing and manipulating radicals? So okay, what we're doing here is we're just going to be rewriting things over and over again. And when I say rewriting things in math, it's basically like this. I have a $20 bill. Can you give me change? That's all they're asking. Okay. So it says, now that Tia and Tahani know that a to the m over n equals to the nth root of a to the m, they are wondering which form, radical form or exponential form, is best to use when working with numeric and algebraic expressions, radical expressions. Okay. So what I want you to think about is like, this is one language. This is exponential language. And this is another language, which is radical language. Okay. I can say the same exact thing, right? I could say the same exact thing in English and in Spanish, but it just looks different when I spell it all out, right? So if I say hello in English, what would I say in Spanish? Exactly. I'd say hola. And so they sound different, they look different, but they mean the same thing. So same thing goes here. They sound different, they look different, but these two are equivalent. The two tens versus the $20 bill, equivalent, but they look different. So Tia says she prefers radicals since she understands the following properties for radicals, and there are not too many for her to remember. N is a positive number greater than 1. Both a and b are positive real numbers. Then the nth root of a to the n is equal to a. Remember, we did that earlier in the jumpstart problem. The nth root of a times b is equal to, now you separate them out, the nth root of a times the nth root of b. And the nth root of a over b is just, again, separate them out, and the nth root over a over the nth root of b. Okay, so Tahani says she prefers exponents since she understands the following properties for exponents, and there are more properties to work with. So she has, when you multiply, we add our exponents and the bases are the same. When we take a power to a power, then we multiply our exponents. When we have two bases taken to a power, we could separate it. This one kind of reminds me of this one right here. Do you guys all see it? This one right here reminds me of this one right here. Okay. A over b to the n is equal to a to the n over b to the n. Again, this one here reminds me of this one here. And a to the m divided by a to the n is equal to a to the m minus n, because we're just subtracting. You guys remember this? As long as a can't be 0. And the reason why they have this like disclaimer, right? You guys understand what a disclaimer is, right? A disclaimer is basically, hey, but a can't be 0. And the reason why is because if you remember a long time ago, someone said you can't divide by 0. And that's correct. Okay. And then the last one that we just kind of finished learning was these negative exponents do not mean negative answers. Who remembers how we talked about it? Negative exponents don't mean negative answers. What do they actually mean? What do they actually mean? Very good. Thank you so much for helping. Someone says divide, Miss Johnson. That's what it actually means. Exactly. So I'm going to divide by n factors of a. Very good. And other people remember it in a different way. I love that you guys are taking these things that we've talked about and really making them your own. That's, for me, that is when you are learning the most, when you are taking something and you've made it your own, right? You're not like repeating Miss Johnson. You're now understanding it completely on your own. And you could tell if you completely understand it when you can answer a question that I've asked and you're not just like a parrot. You're not just like, oh, she whenever she says this, then I say this. Like you're really understanding what I'm asking. So awesome work. I can't wait. All right, so the next part says, both Tia and Tahani agree that it is important to understand the following rule that expresses the relationship between the exponents, right? This denominator is this index, right? And it's still true here, right? And some of you are going to be like more on Tia's side. You're going to be like, yeah, I really like working with radicals. And some of you are like, no, I really like working with exponent properties. My suggestion is to become a stronger mathematician. And you guys are like, Ms. Johnson, am I a mathematician? Yes. A mathematician is a human who does math. So if you're human, check. Do you do math? Check. Then you're a mathematician. Very good. So if you're becoming a stronger mathematician, one of the things that you will do is you will find where you're weak and you will make it stronger by working with that, right? Exactly. So, but there's going to be a preference, right? Preference. Okay. So the next part, it says, using their preferred notation, Tia might write the cube root of x to the eighth as follows. She'll say the cube root of x to the eighth is equal to x cubed, x squared. Ms. Johnson, where'd she get x cubed, x squared? Anybody see, where did she get this from? Where did Tia get this from? Where did Tia get x cubed, x squared? From the sky, Miss Johnson. Got it from the sky. Someone says no. Yes, very good. So someone says, Miss Johnson, this is this. This is this. Very good. Very good. So one more time. We're saying that x cubed times x squared equals x to the eighth. Okay. So they're not pulling anything out of the sky. They're being very, what is it called? Intentional about what they're doing. Very good. So then what happens is they individually each get their own cube root. So cube root, and this. What's the cube root of x cubed? What is the cube root of x cubed? What is the cube root of x cubed? Right here. No. Nice try. I like it. It goes back up here. What's the nth root of a to the n? Because these two numbers are the same, right? Yeah. So this is just x. So I need your eyes to get used to seeing the cube root of x cubed is just x. Do you guys all see that? I need your eyes to get used to seeing this, right? Kind of funny feeling, right? It's almost like the feeling that when we first told you that we're not going to use x as times anymore because later on he has x is going to be x, right? Do you guys remember that? Remember in like second and third grade, you used to use x as times? Okay. So then again, so everybody just say this out loud. The cube root of x cubed is x. The cube root of x cubed is x. And the reason why is because whenever I'm looking at a cube root, I'm going to break it down into its parts. So I know that x cubed is equal to x times x times x, right? And this 3 here tells me, hey, in order to get a complete set, I need 3 of them. I need 3 of them. So because I have 3 of them, this is just equal to x. Okay. So let's just try a couple of numbers just so that we're all on the same page. I need you to figure out 2 cubed cube root. And then I want someone else to figure out the 3 cubed cube root. Okay, so 2 cubed is 2 times 2 times 2, which is 8. What's the cube root of 8? Well, then you go, oh, that's 2 times 2 times 2. Oh, that's just 2. Do you see how this cube root undoes that cube? Do you see how those two just leave you with a 2? Same thing is going to go here. So this is equal to 3 times 3 times 3, which is just 3. So the cube root of 3 cubed is just 3. So this is like me saying plus 4 minus 4, because these two undo each other, right? These two undo each other. That's like saying, let's see, what else do you got? 4 divided by 4, right? These are inverses of each other. They undo each other. Are we comfortable with this? All right. If you are comfortable with this, then I will ask you a different question. All right, fine. If you're comfortable with that, what's the 4th root of x to the 4th? What's the 4th root of x to the 4th? Very good. Very good. Yes, 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 yes. Okay, very good. I got a couple people on there. So can you publicly chat that? Some of you privately chatted to me, and I want everybody to know, no, that's okay. You like, I know what I'm doing. Very good. Yeah, very good. Okay, so we know that x to the 4th is just x times x times x times x. How many to complete a set in this case? How many is going to complete a set in this case? Yeah, 4. Oh my gosh, look, Miss Johnson, I have 4 of them. Very good. Then one of them comes out as a set. Does that make sense? Like so if you're thinking about square roots and you buy a pair of shoes, you expect that both of those shoes that are in that box match, right? So when you leave the store, you have a pair of shoes. In this case, you have a set of 4, whatever. I don't know what comes in a set of 4. I can't think right now. Makes sense? Yeah. Very waffles come in a set of 4. Okay. So then here, you guys are looking at this part right here. What is the cube root of x cubed? What is the cube root of x cubed? I need a couple more people talking to me right now. I have a couple. I need more people. I would really like every single human to help me out on this. So x cubed, cube root. What's the cube root of x cubed? Very good. It's just x, Miss Johnson. All right. So this is x times x. And then what about this one? Do you have a complete set here? Does anybody have a complete set here? For this one, the cube root of x squared, do I have a complete set? No, right? I do not have a complete set. So I don't have a complete set. In order to have a complete set, that number right there, that 3 says I need 3 of them. How many x's do I have right here, you guys? Very good. Thank you for participating. Yes, I only have 2. Everyone say tragedy. We do not have enough. What shall we do? And then everyone's like, no problem. We just leave them alone. If you don't have a complete set, right? You just leave them alone, right? It's kind of like, I don't know, if you didn't finish all of your vegetables, you would have to sit there. You don't get to go out and play, or whatever the case might be, right? So then I'm just going to leave them there. So the cube root of x squared, write yourself a little note. I don't have a complete set. That's why he didn't get to come out and play, right? This is a complete set. This guy finished his homework, x. This guy finished his homework, x. Yes, they are not a complete set, right? Let's just say you go to the store and you're buying a set of 3, I don't know, maybe glasses. You're getting some really pretty glasses for your, I don't know, your grandma or someone. And because you open up a box, and in this box there's only 2 of them, are you going to buy this box? No, you're going to leave it at the store. You're going to be like, you're not coming home with me. It's not a complete set, right? Okay, so then that's why you get x times cube root of x squared. Therefore, your whole answer is x squared cube root of x squared. Very good. So I'm going to tell you a couple places where people mess up. Number 1, they'll forget to put this tiny little 3 there. They think he's not important. He's important, right? That tells me how many is in a set. Okay. So this is Tia's way. Tahani's way is different. Tahani points out that Tia also used some of her exponent rules. She did, right? She really, really did. Okay. So on the other hand, Tahani might write cube root of 8x to the 8th as follows. So first of all, she translates this into exponent land. So this is her in radical land. So she translates it to exponent land. Yes. And then she goes, well, 8/3 is 2 2/3. Remember back in the day, maybe in 5th grade, these were called improper fractions. You guys remember that? So she's already writing it as 2 2/3. Well, 2 plus 2/3 means x squared times this. Because remember, you can add these add these exponents when you're multiplying. So notice you still get the same answer. Here, Tia stayed in radical language, radical land. Here, Tahani translated to exponents, used her rules, and then translated back. So some of you are going to, you'll prefer one over the other. We're going to practice both just so that you can see it. Okay. So we're going to start off with Tia's method. This is Tia's method up here. She stays in radical land. So I'm going to have you try this. You're going to take the cube root of 27 and you're going to stay in radical land. And then once you're done with that, then I want you to try it in exponent land and see which way you like better. Okay. So I'm going to pause and you're going to try it first. Actually, no, I want to do this one with you. Sorry. I changed my mind. So we're going to use Tia's method first. So we're going to go with the cube root of, square root. We're going to do the square root of 27. And if you remember Tia's method, she stays in radical land. So she's going to rewrite her this using radicals. Okay, so the first thing that I want to do is I want to break 27 up into its factors. So can someone break 27 up into its factors for me? 27 equals to what times what? Help me out. Very good. Someone says 3 times 3 times 3 or 9 times 3, whichever one you want to do. I thought about 9 times 3 as well, and then 3 times 3. So I'm going to rewrite square root of, not square root of 27. Yeah, the square root of 27 like this using these here. And I'm going to look for pairs. Do you all see why I'm going to look for pairs? Because this is a square root, right? So what's a complete set in this case? What's a complete set in this case? Yeah, actually a complete set in this case is 2. So I'm going to pull 2 3s together here, right? And then I'm going to leave that other guy right there. Now there's a couple of different ways that Tia would have done it. So just so that makes sense to you. But I'm going to say that some of you are not going to use Tia's method or Tahani's method. You're going to figure out a different method on your own, which is even better. Okay. So in this case, the reason why it's a set of 2 that completes it is because there's an invisible 2 right here. This is the square root, right? There's an invisible 2 here. It just comes with it. So if I ever write you this, if I ever give you this symbol, you can automatically assume that there's an invisible 2 right here. The moment that I put a number there, like a 5, now it's the 5th root. But if I don't give you a symbol, there is a 2 there. Does that make sense? Okay. So what is the square root of 3 squared? 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 What do you guys think? Very good. It's 3. Okay, so very good. So this guy right here becomes a 3. Now, do we do anything with this guy? What about the square root of 3 guy? Does he get to come out and play? What happens to him? Yeah. Yeah, nothing happens to him, Miss Johnson. We just leave him alone. Very good. We leave him alone. Very good. Okay, so we're done with this problem then. So our answer is 3 root 3. So you'll hear me saying this you'll hear me saying and people saying this differently, and you have to get used to like all the different forms that the person is saying. Is that okay? So sometimes I'll say 3 root 3 because this guy's name is a square root. Sometimes I'll say 3 rad 3, short for radical. Whatever you want to say, just make sure that you're comfortable in hearing all of them. Right? Is that okay? So 3 root 3, you're done. Now, some of you are saying, Ms. Johnson, I could have got that done all by myself over here. Right? Yes, you could have, because you would have said something like this. A pair of 3s, Ms. Johnson, you said gets to go outside, right? And this loner 3 here, he has to stay inside because he didn't finish his vegetables. Make sense? Yeah. So when I say 3 radical 3, it could be interchanged with 3 root 3. They're synonyms of each other in our case here. Very good. Okay, so Tahani's method is translating it to exponents. So we're going to translate it to exponents. So anybody know how to translate the square root of 27 into an exponent? How do you translate this guy into an exponent? So I'm going to scroll up and I'm going to show you some of these properties, and you're going to tell me, oh, I understand. Anybody see it? What are you confused on? I want to rewrite the square root of 27 in terms of exponents. So I'm looking for what that can help me do here. And it's all through here. Yeah. So here, we're actually going to use this definition right here. Okay, so let me actually copy and paste that so that maybe that'll help you guys out. Maybe you'll see it better. So I'm going to copy this. So I'm going to use this definition. So you're going to use this definition right now. I'm going to pause really quick. And I want you to rewrite this using this definition so that I can have an expression with an exponent. Got it? I'm going to pause so that you guys can think about this. Okay, so this is just my little reminder to you. If you're a little confused right now, that's good. Right? You're supposed to be a little bit confused if this is your first time ever learning this stuff, which for the most part, most of you, this is. You are supposed to not understand how to do everything completely. Oh, I'll answer that question in a little bit. Okay, so the very first thing that I want to do is I want to figure out how to rewrite this. And when you're first learning a language, right, it's okay to be like, what matches, what doesn't match. Okay, so the very first thing I'm going to look at is who is A? In this case, who is A? Very good. A is 27. So I'm going to write a big 27 because he's my base. Very good. Very, very good. And then I say, okay, that's a square root. What's N in this case? Because here I don't have a number. Here I don't have a number. Yeah, it's 2. Remember that whenever you have a symbol here, this square root, and it doesn't have a number, like up here, they gave us a 3. So that's a cube root. So whenever they don't give us a number, it has to be a 2. There's an invisible 2. Does everybody got that? Because I got a couple people thinking that it's a 3. And I get why you think it's a 3. It's because our very first example, that was a 3. It is not a 3. So what invisible number is sitting right here? Yeah, it's a 2. Very good. Very good. Okay, so then I'm going to say that I'm just going to write a very small invisible 2 there, just so that it reminds me it's a 2. If that helps you, you should do that. You should write it in there pretty often, because it's not wrong if you write a 2 there. It's wrong if you write a 2 there and there's a 5 there. It's not wrong if there's there's an invisible 2 that you're making visible. Okay. And then I need this exponent. So what's my exponent going to be on this this base here? Very good. It's 1/2. Because this 2 matches this 2. This n as the denominator matches that index. Okay, those match. Very good. So does everybody see this? Yes? Okay. And then from here, so going back up here, from here, you're now trying to break it down to look at what 27 is. So I'm going to break down 27 into 3 cubed. See, 1, 2, 3. So I'm going to remind you that, let's see, let's write it over here. So 27 equals, 27 equals 3 cubed, right? I don't like how I wrote. Hold on a second. Okay. So now I'm going to write this as equals to 3 cubed to the 1/2. Does everybody see that? 3 cubed is 27 to the 1/2. And then according to our properties, what are we supposed to do with these two exponents here? Anybody remember that? According to our exponent properties, what do we do with our two exponents? Very good. Yes, we multiply them. And if you forgot those properties, my suggestion is that you kind of just like I do, I just snip this part and put it wherever next to wherever I'm working, right? So yeah, I'm going to multiply those together. So I get 3 to the 3/2, right? And you're like, okay, Ms. Johnson, how does this become that? Well, just like we did before, 3/2 is really what as a mixed number. So how do you write 3/2 as a mixed number? Yeah. So I'm going to write 1 plus 1/2, which means that becomes 3 to the 1st times 3 to the 1/2. And when I look at this 3 to the 1/2, look at this right here, 3 to the 1/2. I am now done. So I'm now translating back to radicals. I am now done. So I'm going back to radicals. So how would I write 3 to the 1/2 as a radical? How would I write 3 to the 1/2 as a radical? Very good. Square root of 3. Okay. So this is the square root of 3. And this is just that 3 from before. Do me a big favor when you're writing stuff like this, make sure that this 3 does not look like a cube root kind of 3, because then your answer is going to be wrong, right? See how big this 3 is? See how it doesn't look like a little guy like that, right? So notice how here you get the same exact answer. Which way did you like better? And you guys are like, this way? Yes, actually, I will tell you though, you working with these exponents is gonna make a difference. Okay. So I'm gonna have you pause. I'm gonna pause the video right now. I'm gonna have you try this one right here. And I need you to try it. Okay. This is again one of those things that students will say, man, Ms. Johnson, that was really difficult. But when I actually did it, it made sense. So right now, I would like you to all start with Tia's method. And when you're done, move to Tahani's method. Okay. Because then once you do it with numbers, then we're going to try it with variables and all other kinds of stuff. Some of you are like, oh my gosh, Johnson, this looks crazy. Actually, this doesn't look crazy. Once you get used to it, you'll be like, oh, that's how we do it. Okay. All right. I'm going to pause. You are going to try it. Okay. So we're going to do this last example, and then you guys are going to be able to try a little bit more for this. So our next example is Tia's method. And the first thing I'm going to do is I'm going to break it down just like I did here. So I'm going to break down 32. And some of you already know how to break down 32 into its exponent parts. So I'm just going to do that really quick. So 32 is 2 to the 5th is what I learned. 32 is 2 to the 5th. Some of you already knew that. That's awesome. So I'm going to go with Tia's method first. And so the cube root of 32 is equal to, now if I'm going to break this up, 2 to the 5th, if I'm going to break up 2 to the 5th into parts, because I'm going to use a cube root, what should I break it up into? What are the two parts I should break it up into? Does that make sense? I don't know if that question makes sense. And of course, my computer is slow. Come on, computer. Yes, it caught up. So how would I break up 2 to the 5th into two things that would make sense? Well, we're talking about twos. So how many twos should go in here and how many twos should go in here? Very good. I want 3 of them in here and 2 of them in here. Now, Ms. Johnson, why would you want 3 of them? Anybody want to know why would your classmate say, I would want 3 of them in here? What made this person say this? Why 3? Yes, exactly. Because we are now recognizing that 2 cubed and then the cube root of that. What's the cube root of 2 cubed? What is the cube root of 2 cubed? Yes, that is why this person did this. Okay, so for those of you who didn't know to break it up into cubed and squared, well, if I broke it up into 4, I have too much of a complete set. And if I broke it into the 1, I don't have enough to complete a set. The whole goal is for me to look for a complete set. Okay, what about this guy? What happens to him? Yeah, leave him alone, right? So we just leave him alone. So we get 2, and then the cube root of 2 squared is my answer. I know, he stays right there. Nothing happens to him. Why, Miss Johnson? Because he didn't make a complete set. So because he didn't make a complete set, we leave him alone. Okay, I'm gonna do Tahani's method super quick. So the first thing I do is I go cube root of 32. And then I want to rewrite. Oh, this computer is like super slow here. And it's still slow. I am hoping that it stays. Oh, there it goes. So there's your answer, 2, and then the cube root of 2 squared. So the very first thing that I'm going to do is rewrite it in exponential land, right? I'm going to write it in exponential land, right? Okay, so we get 32 to the 1/3 is what you guys would have written. And then we already know that 32 is 2 to the 5th to the 1/3. So then now we get 2 to the 5/3, which again, this is the key part right here, is you saying, oh, 5/3, rewriting it as a mixed number. And you guys would say, oh, that's 1 2/3. So that's equal to 2 times 2 to the 2/3, which again, I'm going to use this definition right here. No, not right there. Sorry, right here, where the fraction, the numerator goes outside the parentheses. And then there's a square root. And you can actually put this exponent inside or outside, depending on what you feel like doing. So I'm going to put it on the inside. So this is going to be equal to 2. And so when I write this, this denominator is the index. So this guy goes here, right? And then I just leave it as 2 squared. So that was done in quite a bit of hurry. So I want you to watch this again, this part right here. This part's not new, right? Rewriting it with the fractional exponent. This part's not necessarily new. They're just having you put it all together. Okay. All right. Hope that makes some sense.